So now we are in the Google module, and our first topic in the Google module is search. So what we'll cover over the course of the next week or so, how search works, why it's needed, how it evolved over time, basic search principles and techniques, and towards the end of the lecture, eventually some advanced principles like how Google customizes search results for different users at different times, and Google Instant, which is that autocomplete feature when you start typing something and it offers you suggestions. All right. So search is one of those things that everybody uses. People don't really tend to think about it that much. They don't think about how to super optimize their search. They don't think about what goes on behind that Google interface. It's just you type in some words and hopefully the machines deliver the content that you want to see. Now, most of the time it works pretty well, right? Because Google's been doing this for a while, like 25 years or so, and they've gotten pretty good at it, and they've included some more and more advanced features over time, which we'll eventually talk about. But big picture for the start, data that is highly structured, that follows an extremely regular format, is always going to be easier to search than less structured data. So I'm going to give an example. And the example I will give will be invoices. And I'll draw a picture. Let's draw a picture. Okay. So in case anybody doesn't know, invoices are like records of business transactions. You could think of them as receipts or bills or whatever, but that's all an invoice is, right? You bought some stuff, there's some sort of record that you bought it. Okay, and I'm going to draw this stack of papers. All right, so this here, once I draw in the horizontal lines, this is a stack of papers, very thick papers, but a stack nonetheless. Something like this. Okay, so here we have a stack of invoices. Right, and let's assume they're numbered. Every invoice has an invoice number. And at the top, we have invoice number 999,999. And at the bottom, we have invoice number 0000001. Okay, so we got a stack of invoices and they're all numbered and they are stacked in sequence. Okay, so whenever you have a new invoice with a next higher number, you just put it on top of the stack. Any questions about this? This is good? Okay, so we got a stack of invoices. Now, suppose I ask one of you, retrieve invoice number, well, let's say 720,000. How would you go about doing that? Remember, this is a physical stack of paper invoices. They're stacked in order, and I want a particular one. How would you go about getting a particular one? How would you find it in that stack? And pretend for a moment you're all humans and you're not actually robots.
Break the stack into half several times until you have a smaller stack to sort through.
Well, yeah, but you could do that kind of binary search operation on it, and that's, in a sense, what the machines will do. But here we have more information, don't we? So we don't need to go quite to that extent. How would we actually go about, what would be the first thing we would do in this example? You as a human, you have this monster stack of papers to find one in. How do you do that? Yeah.
I would just go past the middle point since it's higher in the stack. I just kind of grab a little piece on the top and just kind of flip through it and then just see if I get to 7,000.
Yeah. Well, you'd probably start somewhere in the vicinity of this range, right? Because you kind of eyeball and say, yeah, 720,000, probably somewhere in there, right? 72% of the way up the stack. And then you'd kind of eyeball it, right? You'd kind of flip through the numbers and say, oh, look, there's 721,000. So you grab a handful and you're like, oh, there's 719,000. And you kind of try to get in the middle, and eventually you get the right one, right? So a little bit of back and forth. And that's basically what the machines do. The machines pretty much do a binary sorting algorithm where they search in the middle and then they ask, is it on this side or this side? And then they go to that side and they search there and they say, okay, is it between the top and this point, or is it between the middle and this point? And they keep on doing that sort of binary search, cutting the stack in half till they converge on what they're looking for. But basically, this sort of data is pretty easy for humans to work with, and it's really easy for machines to work with, okay? Because it's all sorted by number. Now, suppose we add in, we're gonna change the details a little bit. Suppose instead of invoices, we have a phone book. You know what? Yeah, I can leave this here, that's fine. And I'm going to assume that many or all of you have seen a phone book, whether it's in a museum or at your grandparents' place or something. You've seen a phone book, right? It's a big paper book with a lot of lists of names and numbers. Now, problem number one. Okay, and we're going to say, just like the invoices were sorted numerically, the phone book is going to be sorted alphabetically. So at the top, A, and at the bottom, Z, and everything's alphabetical in there. So problem number one, find the phone number for Smith Fred. How would we do that? As a practical human, how would you go about doing that? How would you go about finding the last names beginning with S? All right, I'll accept that. You open the book in the ballpark of where you accept the S to be, right? Where you expect it to be. And given a fairly standard American distribution of letters, we'd probably expect it to be somewhere like there, right? Maybe a little lower, but not much. It's kind of hard to tell these days, right? Something like that probably. Okay? And then again, we say, oh, maybe I undershot, right? Maybe I opened the book to Sanchez and I got to go a little further to find Smith. Or maybe I opened the book to Sullivan and I went too far and I got to roll it back a little bit to find Smith. But whatever, we eventually converge to the page where the Smiths are, and then within that page, we comb column through column to find the Fred Smith. And if there's more than one Fred Smith, well, hopefully there isn't, but we try to work around that somehow. So again, not a terribly difficult problem for humans. That's why they invented the phone books. That's why they're this way. And not a terribly difficult problem for machines either. Problem number two, though. We'll get back to that in a moment. Forthcoming. Okay, so put that in your mind, put that in your brain for a second. All right. Now, other possibilities, right? Less and less structured data. One thing to think about is, for example, categorized and sorted. So, Amazon. Suppose you go to Amazon, you want to buy a song, right? Now, you could use the site search feature, and that would be a pretty easy way to find what you're looking for. That's what the site search is for. But if you try to find a song using the menus, it's going to be a hassle unless it's one of the few that Amazon is heavily promoting. All right, so you go to Amazon Music, there's a few tabs for different styles of music or, different categories, whatever they may be. And Amazon right off the bat is going to show like the top 10, 20 best that they think that you might buy. So it's basically going to be a popularity contest there, right? And there's no guarantee that if you're looking for some oddball song that's not particularly high selling, it's pretty unlikely it's going to be in those. And it's going to be hard to find. You're not going to be maybe exactly sure what category it's in. You're not going to be sure exactly how far to search down to find it, right? So that is a problem. But the final problem, the extreme case, unordered data like web pages. So web pages, all their content, there is no one single structure for producing a web page. And so that leads to a lot of problems in how we search for them. That's what we'll mostly talk about today. I'm going to come back to the phone book. So problem number two, which is no longer forthcoming, now it's here. Find the address for the phone number 773, 123 4567. Okay, and we'll assume this is a 773 phone book. So it's all, this whole phone book is 773. How do we find the address associated with that phone number? Right? Because the phone book is not indexed by phone number. It's only indexed by last name and first name. So how do we find that address? The number's in there, and the address with that number is in there in the listing, but how do we find that listing? You have to check the entire book one by one until you find it, yes, which is a nightmare. We don't want to do this, right? This is a very large and unpleasant and painful task. This is the importance of indexing. If your data is indexed on a particular variable, like invoice number or last name, you know it's sequenced that way, it becomes easy to find what you're looking for. If your data is stacked up by invoice number, you can just call up Susie at the front desk and say, hey, Susie, I got a question about invoice number 720000, and Susie can type in that index number, and the system can find it really fast. Or if necessary, the humans could find it pretty fast. But if the invoices are all just stacked by invoice number, and you call up Susie at the front desk and say, hey, Susie, can you get me the last invoice from Doug Lundquist in Chicago? And Susie's going to be like, no way, man, because it's not sorted on that. She has to scan through every index from the top on down until she finds it. It's a colossal pain in the ass. She doesn't want to do that. Likewise, phone book. The entries are sorted by last name, then first name. So if you have last name, it's pretty easy to find what you're looking for. But if all you have is the address, well, the address is going to be there in the listing, but the addresses are basically in random order throughout the entire phone book. Not going to be so easy to find. All right, and this is starting to get into the problem of what web pages have. Okay. So, first we can talk about what's in a web page. So web pages have text, they have what are called objects or web objects, all the other non-text elements, things like images, buttons, input fields, text boxes, scripts, whatever, and then formatting instructions. So that's all the stuff that goes into a web page. So text can be shown in a whole bunch of different styles. Objects can be on the page, and there's one of two ways. Either they can be stored permanently with the page, like there's some document that says, oh, I'm using this image and that image, and every time you pull this page, those are already there. Or it could be automatically constructed. For example, suppose you do an oddball search on Google, right? Some search that Google's never done before. Well, it's not going to be cached in Google search results because nobody's done it before. So what's going to happen, Google is going to have to run that search through its own systems, produce a set of search results, somehow construct an HTML document out of that, and return that document to you as a web page. Or same kind of thing. Suppose you go to Yahoo Finance and you want to get historical price quotes for IBM from 1986. Well, Yahoo doesn't have that data just sitting there in a permanent web page, right? Because there are so many different possible combinations of stock data that people might want. So what it has to do, it sends a call to the database saying, hey, this user wants to see such and such stock data, runs that query on the database, pulls that data out, fits it into some sort of HTML object, right? Probably going to into some sort of grid table, and then constructs that HTML page and sends it to the user. So that's how web pages happen. Also, objects themselves can have metadata, things like their labels, things like display priority, right? Is this something that goes in front of text, behind it, whatever, and even preferred size. Like images can have tags, identifying what the image is of. And all of these different elements can be combined in pretty arbitrary ways, so there's no meaningful way to order web pages. There's no, like with an invoice, right? You could give a stack of invoices, each invoice gets a number. Web page, yeah, you could give each web page a number, but it wouldn't have any meaning as far as the content of the web page. Excuse me. All right. Now, way back when, well, let's talk about markup languages, and I'll tell you why we have them. So web pages are written mostly in HTML, right, which stands for hypertext markup language. Visually, HTML looks a lot like that XML that we saw in the object description languages a while back. So there are pointy brackets with tags, and the tags describe what all is in, how the content should be displayed. So what markup languages are for is it's like an automated editor. So imagine you're a writer for some newspaper, and you have a bunch of raw text, right? You have your article, you send it to the editor. Well, the editor is going to look at it and say, oh, this part's a big headline, this part's a smaller headline. Some elements are going to be in bold, some of them are going to be in italics, the paragraphs, the columns are going to be so wide, whatever. Things like that is what the editor does. That's what markup languages do. Markup languages take a raw text document and provide essentially formatting instructions on it. And the way that works is that there are tags. The tags are labels that specify how a given chunk of text is going to be displayed. So on the next slide, we have an online news article example. There's going to be some tags that display text as headers. There's going to be the article body that won't be enclosed in tags. It'll just use the default style. And individual words or phrases can have other tags showing that they're going to be italicized or in boldface. So let's go on here. I'm going to lift this and go to the W3 schools. Let me put it in Notepad first, though. I'm going to close out these two paragraph tags here. Strictly speaking, I don't need to do this. I'm just doing this for clarity. So W3 schools, online HTML editor. There we go. Boom. Okay. So this is one for W3 schools. I like this one because unlike many online HTML editors, this one lets you do a little bit of JavaScript as well. Although sometimes other ones are pretty fussy about that for security issues. All right, so what we do, we post the source code here in the code panel. Right, this is all the raw HTML code. And then once I click run, it'll display over here like HTML, like a web page. So that's how it's going to look. You see this first line, H1. H1 is a big header, right? It's the biggest text in the document. H2 is a header. You can see it's still bigger than the other text, but it's smaller than H1, so it's a smaller header. This P tag here, this is a paragraph indicating that this chunk of text is going to be separate. There'll be a space between this and the paragraph following it. You can also see the word donuts here is surrounded by B tags, B for boldface, and you can see donuts is bold there. Likewise, fresh delicious donuts over here is italicized. You can see that that's inside an I tag for italics. And last, down here, we have an A tag. A, for some reason, is the tag for hyperlinks, right? So if you want to have a link to another page, you put it there. Now, the way it is right there, there's actually, this link doesn't go anywhere. If I want the link to go somewhere, I have to give it an href attribute, href for hyperlink reference. And then I can put a URL. I can do https www.mcdonalds.com. Okay, and when I run this, now it appears as a link, and I can I can hold control and click on it, and it'll bring me to the McDonald's page. It's actually a functional link there. Okay. So that's our quick single slide introduction to HTML. You'll get more of it when we do web design, but that'll do for now. Now, you might ask, well, what's the origin of all this? Why are there markup languages? Well, good question. Good question. So way back when, circa 1990, when all this stuff was being developed, a lot of computers still used very basic computer graphics. And one of the standard ones was the Commodore PET. Very popular in the early 80s. Commodore PET looked like this, right? If you asked, hey, show me an old-timey computer, this is about what you'd think about, right? There's all the stuff is built in as one unit. The screen, it's monochrome. If you look at what's there on the screen, if you zoomed in, you would see that it only uses one font. Multi-font machines, the first one I became aware of was the Mac Classic, that little oddball one in the late 80s, around 86, I saw my first Mac Classic, and that allowed different fonts. But through the early days of the internet, a lot of computers just had one standard font that they used, and so there wasn't any real need for HTML to be able to display different formats for text, right? Because whatever text was there was just going to get shown on the machine's standard format anyway. But again, as different styles became available, then yeah, HTML, the specification for that expanded to include all that style formatting stuff. Okay. Now, we're good. Okay. Questions on any of that? Anybody, would you like to know more? All right. Okay, next thing, how online search works. Well, the first big question is, what pages contain text that matches the, at least, if not the exact words, at least the meaning of the words that the user entered. So text matching is the main thing for returning search results. For example, page titles. If you have some text in a page title, you can infer that that's probably what the page is about, because otherwise, why are you putting it in the title? Likewise, headers. They're not as big as the page title, but they generally indicate, hey, here's what a section of the page is about. And so if you can't find a page that the whole thing is about some topic, well, finding a section that's about it is better than nothing. And failing that, plain text, right? Ordinary text throughout the document that's not a header or not the title. You can also find matching as image or other object metadata, right? So for example, suppose it's a site that's selling shoes, there might be images of shoes, and some of those images will have in their metadata, hey, women's shoes, size 12, men's shoes, size 8, whatever. Also, Google has gotten pretty advanced in the last 25 years or so. When I first started using Google in the late 90s, it was basically only exact text matches. If you didn't put in the exact word, you didn't get it, right? So, but over time, they included features like spell checking and other assumptions about what the users actually mean, assessing meanings of terms, including plurals as a match for, just the singular form of the word and vice versa. So, for example, one of the basic things there is synonyms. So if you type in bugs, chances are Google's going to think you're interested in insects or creepy crawlies generally, right? Not something else that might be considered a bug. So the default thing, probably if you're typing in a search for bugs, you're going to get some stuff about insects. However, if you include some associated terms like computer bugs or software bugs, then Google's going to say, oh, you mean a different kind of bugs. You mean flaws in the hardware or software. That's what those are. So if you include that topic, you're going to get a very different set of results from just typing alone bugs. Likewise, misspellings. So when I first started when I first wrote up this course 2016, and I included this bit in the slides, BGUS, actually if you type that into Google, it would return bugs, right? It would say, oh, we think you meant bugs. And I considered, well, BGUS might also be bogus, but bogus is a pretty rare word to type in, and it's a pretty odd typo to make to miss that O. So yeah, that's kind of a rare one. But what it actually does now, if you search for BGUS, is it gives you this. Bowling Green State University, which is actually BGSU. All right. But if you roll down a little bit, you can find that there are some various types of components, BGUS, right? Linear gate openers. There's apparently a BGUS whole line of those. Who knew, right? It's an odd search, but whatever, there it is. On the other hand, if you provide context, like putting in software BGUS, then Google says, oh, software BGUS. You mean software bugs. The presence of the word software, that context profoundly overrides, the initial guess they did to make it Bowling Green State University. So anyway, interesting stuff. We'll have more to say about that before it's all over. Now, matches to search terms, right? So number one, ideally, a user could enter in some set of search terms that would correspond to one and only one page on the internet. But most of the time, that's not even close to realistic. So I'll give you an example. I'll give you a few examples. What do you think is a popular single word topic on the internet? And don't say porn, because I'm not going to search for porn in lecture. Okay? All right. So give me a single word topic. What you got? NBA. All right. NBA gives you about 1 billion results. Not bad. We can do better, though. What's that? Dog. Excellent. All right. Let's try that. Dog. 5 billion. Okay. We're going to generalize. All right, so we're going to take basketball and go to sports. Sports gives us close to 15 billion hits. That's a lot. Let's see pets. Pets gives us still about 5 billion. Okay. I'll do a couple others. Money is always a good one. Money gives us about 8 billion. And the big one this morning was news. 17 billion. It's weird though, the numbers change over the course of the day, right? When I did this one, news this morning, news got 19 billion and now it gets 17 and I don't know, whatever. Okay, so the point is you could potentially get a lot of different search results from stuff. But even if you enter in a bunch of oddball terms, let's get some oddball terms. Give me some oddball words. That's not that oddball. Oh, wait, we'll do it the regular way though. We'll spell it properly. Yeah, what'd you say? Caterpillar, excellent. Okay, what else? What's that, tuxedo? Ooh. One, banana, we do odder than banana. What's an odd fruit? Durian is pretty odd. All right. I would have accepted dragon fruit. Durian's good. Okay, so we're going to run this. And we see these words have very little in common, and we would think it would be pretty unlikely they would all appear on one page, wouldn't we? 9 results. What can you say? Okay. Although, yeah, it shows the results for Fortnite. Let's see about this one. 280,000 results for that slug of terms. All right. So what I'm saying, trying to come up with some terms that are uniquely only on one page just isn't a practical option. It's just not going to work that way. So Google has to do a whole lot of ranking effort to really try to figure out the best pages to match your terms. Because even for something like this, you're not going to go through 300,000 pages for a really, really weird search. Okay. Now, okay, so common words, of course, often found on a wide range of sites and pages. For example, if you're looking for a shoe sale, if that's your search query, you could find those words on, of course, on a shoe retailer, which is probably where you'd want to find them, but you might also find an article about a shoe sale, or you might find the 2 words shoe and sale in separate sentences or paragraphs on a completely irrelevant page, right? On a page that has nothing to do with shoe sales. So the way terms appear on a page is their context, and that's important. So first thing, prominence within a page. Text that appears in the title is considered more important than ordinary text on a page because the title of the page says this is what the page is about. So if you see shoe sale in the title, you can reasonably infer the page is probably about a shoe sale. All right. Also, distance and sequence. If the 2 words shoe and sale appear together and in sequence, that's going to be considered a better match than these shoes are for sale, where the shoes are in sequence, but they're separated. And that is going to be better than the next example. I went to Target for their annual sale on socks. Ironically, I lost a shoe there. The 2 words are present, but they're in reverse order and even more widely separated. Okay, so there's context that helps determine, even though a whole bunch of pages might have those terms, some are better matches than others. Other factors like repetition, right? If the same words appear multiple times on a page, you have increasingly more confidence that that's what that page is about. So if you're a shoe sale page and you have these shoes are for sale, these shoes are for sale, these shoes are for sale, big shoe sale this weekend, right? If the words are there multiple times on a page, you become more and more convinced that that's what the page is about. Also, search results for a term these days, they get affected by other terms in the search, especially if they radically change the meaning. For example, both search queries Bear Cubs and Chicago Cubs, they contain the word Cubs, right? So you could conceivably have, if there are some new Bear Cubs born at a zoo in Chicago, both of those search queries could conceivably return some of the same pages. But what Google's probably going to do is look at Bear Cubs and say, oh, Bear Cubs, that means a specific thing. That means a baby bear. And we're going to look for pages about baby bears. Whereas Chicago Cubs, that's a baseball team. Nothing to do with real, animals. So we're going to look for pages that are about sports because we know Chicago Cubs is a phrase with a distinct meaning from just the 2 words separately. Google also uses user location and history, right? So for example, if you're in Australia, it is possible that a search for Cubs will return very different results than a search in Chicago, right? If I'm in Chicago and I search for Cubs, come on, Google's going to figure I'm interested in baseball, right? But if I'm in Australia, where they're not too concerned with American baseball generally, and they have a lot of weird baby animals running around, yeah, Cubs is probably going to return something different. Okay. Now, the art of searching. So search is an interesting thing that a lot of people really aren't very good at it. It's always kind of strange. So, I mean, the trick is basically to try to come up with a set of words that's pretty narrowly focused on what you're looking for and doesn't include like a lot of extra scope for other stuff. So the example I give, I remember back, I think it was 2021, my wife and I, we had, the kids had COVID, right? And they needed to go get a COVID test. So, you know, we could prove we got it so they could eventually go back to school or qualify for remote learning or something. So my wife, she's like tearing her hair out for like 10 minutes. She's trying to find a way, you know, to figure out where she can get, you know, a same day COVID test result. And after 10 minutes of searching, she's finally like, oh, fine. If you're so smart, you do it yourself. And I, okay. So I got my phone and I, you know, I don't know what exactly she'd been typing in for her search, but it wasn't working. And I just typed in, you know, COVID test and whatever the code is, like I think they call it a PCS, the one you get like the same day, COVID PCS test near me, something like that. And ding, you know, I got a link to some CVS just down the road for us. And I went in and made an appointment. And I said, there you go. You're welcome. So I don't know. Some people, you know, my wife's smart and all, so it's not that. It's just, I don't know. Some people write bad searches. Okay. But intuitively, if you use less common and more precise words that closely match a topic, you're going to get what you look for, right? Now, I think what my wife may have done is done something for like same day appointment, right? And I think that none of the pages she was looking for had that exact text, you know, same day appointment, or the ones that did, they were already swamped and there wasn't anything available. So when I did that same search and I did it without those terms, maybe that's what tipped it. Anyway, but if you're doing a good job picking the terms, number one, you're going to get fewer matches, and that always helps. Number two, the really relevant matches are going to be closer to the top. So hopefully, you know, they're in the top few results, and certainly you won't have to scroll through page after page of search results trying to find content that's relevant. And of course, all these associations that we talk about between terms, those are important as well. So, for example, suppose you're doing a search for unemployment statistics, right? And I'll just go through what we have here. If you're going through, and suppose what you really want is unemployment statistics regarding Rockford, Illinois in 1982 when they briefly had the highest unemployment in the country. So suppose you look up unemployment statistics. Well, Rockford is a small part of the United States. 1982 is a small part of the entire set of recorded unemployment statistics. So when you just search that, yeah, I mean, those results will be in there somewhere, but you're going to have to scroll way, way, way far through it to find it, right? What shows up at the top is just broader federal measures, right? So national unemployment blurb there, U.S. Bureau of Labor Statistics, you can find some stuff, other things, you know, whatever. So you can find some more big picture data. But if you're like, okay, I want to circle in on 1982, and of course, you're going to get more data from that, more pages from 1982. Generally, only pages that include the year 1982 are going to show up in that mix, right? So here, you know, again, we get a blurb, we get some other stuff from the Bureau of Labor Statistics, blah, 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 other research, whatever. But if we want to specifically find Rockford, okay, include Rockford, and yeah, then there you get it. Okay, so we had that there. I grew up in Rockford during that time, you know, in that those Rust Belt days, and it was not pleasant. So that's all I have to say about that. Okay. Now, why is search essential? Well, prior to the early 90s, the internet was basically like a big message board. And I hope that you all know what message boards are, because I don't really want to explain them. But the idea is there weren't that many information repositories, right? The internet in those days was still a pretty specialized tool for universities, government agencies, military, whatever, doing various kinds of research. That's what it for. It wasn't a place where you go to see, memes about, cats laughing or something. I don't know. It wasn't like that. So basically, who was using the internet? Serious professionals mostly. What were they using it for? To share serious research topics. So there weren't that many of those places. And when you did get to one, it was all neatly organized in file folders. So you'd say, okay, I'm going to go look at MIT's archive of, quantum physics research. And there'll be some folder for physics. You dig around in there, you find the quantum research projects, you find the page for whatever particular resource project by whatever particular faculty dude is working on it, and you find that stuff there, right? So it was basically like digging through a file folder system. And back in those days, again, there weren't many categories. These kind of simple tools that they have, you just had these text-driven tools, basically like the command window. So if you have, I'll bring up the command window. There we go, because I brought it up this morning too. It looks like this, and this is what they use, and this is what they used before Windows for DOS, Disk Operating System, to navigate around through your file system and launch files and things like that. It's basically like that. It wasn't much, but 1990, we were glad to have it, so whatever. And it was enough. But as time went on, there were many, 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 many more pages. Number two, those pages were stored in a much wider array of locations. And those locations started having so many different pages, it became increasingly difficult to categorize them, right? So imagine if you're, you start having sports articles. Well, okay, fine. We're going to create a folder for sports. But then, it's not just sports, is it? There's baseball, and there's football, and there's rugby, and there's basketball, and there's hockey. And if you're in Canada, I guess there's curling, right? You start branching off all this other stuff, and you have different terms. And how do you categorize all that? It becomes increasingly difficult to do. In fact, there's a lot of content that is not easily or precisely categorized, right? It just doesn't neatly fit into one category. You can throw a few, you can throw a few tags at it. Like imagine if you have some article about a film, but it's more about production problems during the film, right? It's not a review of the film. It's not the film itself. It's sort of a business discussion of operations management about, actually making the film and stuff that went wrong. That's kind of a weird thing. How do you categorize that, right? Anyway, so that was the sort of problem that people started to see, is there became a lot more pages, a lot wider variety of topics, more places they were stored at. Search became much more difficult to do. It became a lot harder to find what you were looking for because it was harder to describe what you were looking for. Now, just to give you an idea, so 1991, you'll see there's an asterisk over there. And if you actually go to the site that this is from, you'll see it says there is one website there, right? The first website launched in 1991. And then, of course, it starts exponentiating. It gets pretty big until at the end, 20 years later, there's like 2 billion websites. Clearly, there's been some consolidation at various times, but there's a lot of websites out there. Right? It's obviously, even if, hypothetically you say, well, maybe we could have handled this variety in 2000 just with those text command tools. By 2021, no way. Just no, not going to work. Second thing, web page weight, right? So the web pages themselves over the last 20 years, 30 years are getting vastly more complex. So this, I like the chart, which is why I kept it, even though it ended in 2014, because it's sufficient to show the trend, right? I don't need to figure out exactly how many more web objects there are on pages than there were 10 years ago. This is when the damage was done. So 1995, that green dot there on the lower left says 2.3. The average web page had 2.3 web objects. So that means basically maybe an image, maybe a link, maybe a button or a text box or something. And that's about it. The average page doesn't have much. So it's not very useful to discriminate across pages because there just aren't that many web objects on pages, right? But compare that to 20 years later in 2014, the average web page has over 100 web objects. Suddenly you could say, hey, maybe we can use these, what's in the web objects themselves, their metadata, their arrangement, to try to figure out how to deliver better search results. So Example, suppose you're looking to buy some shoes online, okay? What sort of web objects might you reasonably expect to see on a reputable shoe retailer site on the web page itself? What would you expect to see? Yeah. You would expect to see some images of shoes, right? Sure. And those images would have, various things in their metadata, right? Like, shoes or boots or athletic shoes, whatever, something like that. Good. So images, that's one. What else? What mechanism would you use to buy shoes online? Would you write down the address of the shoe retailer and send them an envelope full of money? What's that? Right, but I'm talking about web objects. What web objects would you use to facilitate the transaction? Right, because you're not just going to send Zappos an envelope full of cash, are you? So what would you need? What would a reputable shoe seller have on their website? Yeah, but how would that translate as an actual web object that you could look for? What things would be there? Yeah. Like a shopping cart feature, right? We would reasonably expect to see a shopping cart feature on an actual retailer site. Good. And one more. Suppose there's an image and there are size options. How would you go about selecting size options, which is surely something that a reputable shoe retailer would want to provide you? How would you select size options for shoes? What's that?
Buttons.
What kind of buttons? Regular buttons. Maybe. One, I would accept drop menus as a first choice. You might also find radio buttons. Radio buttons are where there's a set of options, but you can only click one at a time. If you click one, it clears the others. So things like that, Google can say, hey, the sites that people go to, they look like this. The sites that they're happy with, they look like this. Other junky sites, they might not have these same features. They're going to be, pushed down in the rankings. Okay, Google can use those web page objects to deliver better search results. All right, come back on Wednesday. We'll talk more. It's been a hoot.